So guys, you can see that the 4 counters are working, 1, 2, 3, 4, 2 on first row, 2 on the second row. See, they 4 are working like a charm using PIC16F877A on a 16x2 LCD. Hello guys, welcome to learning microcontrollers. In this video, I will show you how we can run 4 counters using single variable on LM016 16x2 LCD using a PIC16F877A microcontroller. And the compiler software we are going to use is a micro C for PIC. I'm going to make a series on these videos that how you can use more than one variable to run more than one counters, or like you want to display values, like you are making an energy meter, you have like 3 to 4 values, then how you can implement that, because I get a lot of queries and a lot of requests that they cannot run like more than 2 values on this 16 cross LCD at the same time. So in this series, in which I will tell you how to use this LCD for displaying more than one variable data at the same time, this series will greatly help you in that perspective. So let's get started. So the first video will be like we will be running 4 counters using one variable with PIC16F877A microcontroller. So let's get started. So guys, this is our PIC16F877A. First of all, let me show you how you can connect this LCD to the PIC16F877A. Then I will simulate this on the Proteus, because if you do the connection on the Proteus, that's a different story than you do the connection on the actual hardware. So let's get started. So guys, this over here is a 16x2 JHD LCD, also known as LM016 LCD. It is easily available in the market and you all are, I think, easily familiar with this. Now guys, to interface this with a PIC, you will need a 10 kilo ohm variable resistor like this. It has 3 pins like this. It is also mentioned on its body as well, 1, 2 and 3. This variable resistor will be used to adjust the contrast of the LCD. Now let's do the connections. For the connections, you know that this LCD has 16 pins from 1 to 16 from left to right if you hold it like this. Now guys, connect the pin number 1 and 5 of the LCD, then you connect it to the pin number 1 of your potentiometer, and then you send it to the common ground of the PIC like this. In this way, our LCD and the variable resistor both are grounded with a PIC. Now guys, the next thing is pin number 3 of your LCD is the contrast adjustable pin. You will connect it to the adjustable pin of your potentiometer. In my case, this potentiometer pin number 2 is the adjustable pin, and you connect it like this. Now guys, pin number 2 of your LCD is the power pin. You power up the LCD using this pin, so you have to give 5 volt to the pin number 2, and you connect it to the pin number 3 of your potentiometer, and you then send it to the 5 volt supply, and the same supply which is powering up the PIC will power up this circuit as well. In this way, your LCD is powered up using 5 volt and your potentiometer as well. Now guys, pin number 4 is the RS pin. Now you can use any available digital input output pin of your PIC microcontroller to connect this with. If you use any other pin than the one I'm going to use, you just change it in the programming. I will show you how you can do that as well. So I'm going to connect the RS pin to the pin number C0, that is pin number 15 of the PIC like this. Then for the pin number 6, that is the EN pin, you can again use any digital input output pin of your PIC. I'm going to use a pin number C1, that is pin number 16. Now for the data pin 4, that is pin number 11 of your LCD, I'm going to use a pin number C2. For data pin 5, it will be D2. For data pin 6, I'm going to use D3. For data pin 7, I'm going to use the C4. Now pin number 15 or 16 are for the LCD backlight. Remember, you will only connect these 2 pins 15 and 16 if your LCD have a backlight. In case your LCD don't have a backlight, then you just leave them alone. You will not connect them at all. So in my case, my LCD do have a backlight, so I connect the pin number 15 to the VCC and 16 to the ground like this. Now these 4 pins 7, 8, 9, 10, they are for the 8-bit mode. If you use the LCD in the 8-bit mode, then you will need to connect them, while in my case, I'm going to use this LCD in the 4-bit mode. So I will leave them floating. In this way, our connections are completed. Now let's get to the Proteus and make this on the Proteus as well before we move on to the programming. So this is the Proteus here. I'm going to use the Proteus 8 demonstration version, and go to the left. Here you have this P, and also remember, this is the ISIS here. You first go to the ISIS schematic capture, then you click on the devices, this P PIC, and write down PIC16F877A like this. Now you place it wherever you prefer. Now go back, select the other component, that is the LM016, sorry, 016 like this. This is the LCD here, LM016 16x2 alphanumeric LCD. Place it next to your PIC like this. Now guys, again go back and bring a variable resistor, write down variable resistor like this, and the one you need is the 10 kilo ohm. So look for the 10 kilo ohm. This one is the 10 kilo ohm. Just take it and place it anywhere you prefer. Now guys, to make the connections, go to this, let me zoom in. Okay, go to here, these two bars, terminals, and here you have this power. Place it above here. Like in case of actual hardware, this will be your power. For the simulation purpose, I am only going to demonstrate the programming over here instead of the actual hardware. Now this is the ground. Okay, place it down here. Now do the connections. Power goes to the power end of your variable resistor, ground goes to the ground end of your variable resistor like this. Now guys, for the LCD, do as shown in the presentation. Pin number 1 and 5 will go short them, and then to the common ground with the potentiometer like this. Now here pin number 3 is the adjustable pin of your contrast. So you just give it to the potentiometer adjustable pin like this. Now pin number 2 is the VDD, that is a power pin. So you send it to the 5 volt supply like this. And now guys, RS pin, this will go to the pin number C0 as shown in the presentation. So just C0 over here. This is the pin number C0. For the EN pin, we are using C1. So I send it to the C1 like this. And now for the pin number D4, I am going to connect it to the pin number C2 like this. This is the C2 pin. For the D5, I am going to use a D2. D2 is here. For D6, I am going to use the D3. And for the D7, I am going to use the C4. Okay, in this way our connections are completed. Now guys, what we are going to do is that we just go to the micro C4 PIC and start programming. So let me zoom in. I am going to use the version 7.2.0. Latest version is also available, so you can use the latest version. Latest is always better. Click on new project. This window pops up. Click on next. Write the name of the project. I write multi 4 counters single variable tutorial by learning microcontrollers. So this is the name I wrote. You can write any name you prefer. PIC16F877A is the microcontroller, and the crystal I have connected to the pin number 13 and 14 of my PIC board is 20 megahertz. So I write 20 here. Click on next and finish. Now guys, this window pops up. Before you do anything else, first of all, save your work. Press Ctrl S. This will save the work. Now go to the right, select the libraries you are going to use. First of all, select the library, conversion library, because we will need to convert the integer to string, because we cannot display integers directly on the LCD. And C string is auto selected. Now the LCD library, here we go. First of all, go into the LCD library. This command LCD I90, double click on it. This window pops up, and here in the example you have these commands. You copy them till here like this. Go back, paste it above the void main like this, paste it here. Now what you do is that here you will define your pins. If you use any other pins than the one I choose, so you will simply do the changing here. For the RS pin, I am using C0, so I make it C0. If you were using B1, then you will make it B1. If you are using D2, then just make it D2. That's all. For the EN, I am going to use a C1. So if you are using some other pin, just name that pin here. And for the data pin 4, data pin 7, I am going to use a C4. For data pin 6, I am using D3. For data pin 5, I am using D2. And for data pin 4, I am using C2. Now this is done here, and now do the same for the direction, exactly the same. For the RS, it's C0. For the EN, it is C1. For D7, it is C4. For D6, it is D3. For D5, it is D2. For D4, it is C2. That's all. Now guys, what you do next is that you go back to the LCD I90 library, double click on it, go down here, you have this command LCD I90, you copy it, go back, paste it in the one time loop like this. and also give some initialization delay like this. 200 will do fine, or it's not necessary, but I always suggest you give it in the one time loop. Now guys, the LCD is initialized. To check is our LCD is working or not, we just output something called hello world. So go to the LCD INIT. Here below that you have this command LCD out. Double click on it, and here in the example you have this command. You copy it, paste it below this here. So it will just display hello. Start writing from the row 1, column 3, and it will display this text hello. So let's see, does it work? If it works, then we continue, else we see if there is any error. So what I do is that I double click on this Proteus and select the crystal. We have set 20 megahertz in the programming, so in the simulation as well it will be 20 megahertz. Now go to the place where you created your hex file. I had created it on the desktop. So here it is. I select it, click on OK, run the simulation. Okay, it is working like a charm. You can see the cursor. I don't want the cursor. I will remove the cursor, and rest the wiring is fine. If the wiring, any wire was not as per programming, then this was not to work. So this is fine. Now we continue. So first of all, we will remove the cursor because I don't want the cursor. If you want to keep the cursor, you can keep it. Go to the right to the LCD library. Here you have this LCD CMD command. Double click on it. This window pops up, and here you have this command in the example LCD CMD LCD clear. This command basically clears the screen. Now remove this. We have tested it. Okay, remove whatever is inside the bracket and go to the right again to the same window LCD CMD, and here you have this available LCD command table. Look for the LCD off cursor, this one. Now copy this green text here from the LCD command side and paste it inside the bracket. Now this command will turn off the cursor. Now the cursor is off. Now we clear the screen. Go back to the LCD CMD. Clear the screen. If there are any rag bagged values, it will be cleared up before the code begins. It is better to give some delays in the one time loop for the smooth functioning. I give a 20 millisecond delay for each command like this. Now guys, we are ready to go to our forever loop. Our LCD is initialized and it is working. Cursor is removed and LCD is cleared for forever loop. Now write down while 1, starting here, ending here. Now this is our forever loop, starting from here, ending from here. Now inside it, what I do is that I go to the above the void main. Here I take an integer increment. I will make 4 increment counter, and then we cannot display the integer directly on the LCD. What I do is that I also, you can see, like take a char as well. I write char inc1, and maximum digits it can have is like 10. So that's all. So this will be an array of char is a string. So it's an array of char, it's a string. So we cannot display an integer directly on the LCD. We will use a conversion command to convert this integer into a string, and we will display this string on the LCD. Now first of all, what we do is that we make a counter. So you can use for loop, do while loop, whatever you prefer. I'm going to use a do while loop, do, and then this is a syntax for the do while loop, while, and here inside it we will write our condition and then the ending semicolons like this. Now what we do is that I write here increment equals to increment plus 1. Like increment will increase by 1. This will be a counter, and once the increment is less than 100, like it will be less than 100, then the counter will stop. Okay, simple. Do start the counter, increment the increment by 1, this variable, and once the increment is greater than, like, only it will allow the loop to repeat if it is below 100. Once it go above 100, then it will be terminated. Now why it's less than 100? Because one in the do while loop, first run is free, like it will run first time at any cost. So it's like a totally 100. Now guys, what I do is that increment is done. Now we need to just display the variable. So whatever the value is increment here, we will display it, and by default we make the increment 0. That increment is equal to 0 when the code starts in the one time loop. Now by default it's 0. What I do is that I go to the right in the LCD library. There is LCD out command. Double click on it. This command over here again. Now copy it, bring it back, paste it here. Now here, instead of having this, we will display the increment. Now the value of the increment is defined. Now we cannot display this integer directly on the LCD. We have to write something here. which will be displayed on the LCD. We cannot display integer directly, so we will convert it into a string. Now go to the right here in the conversion library. You have this command int to string, this command, double click on it, and in the example here you copy this command. Now how this command works is that this is where you will write the integer, and this is the variable in which that the integer, this is the increment, will come here like this, and this is the variable in increment 1. See, this is the integer variable and this is the string variable. So whatever is in the integer variable will be converted into a string and stored in this string variable, and this we can display on the LCD. So I place it here. So whatever is in this variable will be converted into this variable, and then it will be displayed on the LCD like this. Now this will be displayed at first row, first column, one counter. So we will need to display 4 counters. So I give some delay, like I take a delay of 200, like counters will run with a delay, and also I give delay to each command, like 20 millisecond delay here, 20 here, not necessary, but I always suggest to give it. So 20 here, 20 here, so it is like 160 now. I had divided a delay, so total it is 200 for 1. Now the counter has been incremented by 1. What I do is that the next thing, I display it the second time. Now for the second time here, it will now display at first row, 8th column, that is the second counter. This is the first counter here. Now this is the second counter here. Now I display the third counter, and third counter will be on the second row. So row 2, and from the first column the third counter. Now the fourth counter, the same value will be displayed fourthly at this place, and we make it on the second row, 8th column, the fourth counter. In this way our 4 counters will keep on incrementing by 1. And now the increment is on the start, we will not be able to see the 0. What I do is that I move this command to the end. So in this way we will be able to see the 0 as well. Once the counter is over, increment will again become 0 for the next run, equals to 0, because if we don't make it 0, it will be above 100, and once it comes here the condition will terminate the counter and it will keep on repeating. So that's why we will need to make it 0. Simple as that. Let me tell you what this code is doing here. Okay, give this here, delay here. Okay, what it is doing is that first of all we simply convert the integer to string, whatever the integer increment is, and by default it is 0. So it will be 0 on the LCD. It will be displayed at the first row, first column, then it will be displayed at the first row, 8th column, then we will display it at the third time, second row, first column, then the same will be displayed at the second row, 8th column. So in this way we will have 4 counters with 1 variable. So increment is our only variable. Now the increment will increment by 1 and the loop will repeat, and now it will display 1, and similarly it will keep on going until it do not becomes equal to 100 or 99. It is less than 1, it means 99. So that's all. So I build the code, check for errors, no error. Okay, let's go to the Proteus and run the code and see what happens. So I click on run. Okay, see the 4 counters, they are incrementing by 1, simple as that. See, people usually complain that it is not possible to run on it various counters like this. It is just about the technique. So now we are only using 1 variable in this video. In my next video I will go with 2 or 3 variables, and then I will show you what is the difference and what other techniques you can use. And in the next video I will tell you how to use the LCD char command. Right now I did this using LCD out command, and in the next video I will be using LCD out CP command, how to use a cursor. So guys, simple as that. If you guys have any questions, you can ask me in the comment. Thank you very much for your time and have a nice day.